Let's look at question 62. Unique path. In this question, you will imagine you have a robot in a grid. This grid is m times n. So every time robot only can move right or down. And then by this way you can build a path from the left top corner go to the right bottom corner. This is the one path. And return how many total paths, unique paths, if they give you a grid, mn grid. So for this question, we should learn something, right? So first, unique path m n should equal to n m, right? So by this question, actually the answer, we use recursive. We can quickly find the solution, but maybe it's not efficient. What is the solution? So if m is 1, if it's one line, it's only one path, right? Return 1. Else n is 1, return 1, right? Then what we can do is else return unique path m n minus 1. We let it from this location, they can have two options, going down, going right. So this is going down. This is one path plus is m minus 1. This is a go right n. Let me try this one. Else if. So actually this is the solution. However, I think this is will run long time if you have a big m and n. Okay, but how we can improve the calculating? We should use the dynamic programming. So what is dynamic programming? It means you see, when you do this one, some paths you already calculated before, so you do not need to calculate again. What is that one? For example, you have m equal 5 and n equal 5 or equal 4, right? So by this way, you will calculate m minus 1 is 4 plus 5 3, right? Go to down, go to right, and this 4 will become the 4 3 and 4 3 4, right? And then 5 3 will become the 4 3 and 5 2. So 4 3 3 4 4 3. This is the same number. If we calculate 1, we can ignore all other two, right? So we should calculate and remember the result we already have. Okay, so now we have the new function called recursive, this one. and by this one we do it. And in the recursive, every time we can ignore some calculation if we already did before. Okay, so recursive, this one, m and n. Okay, let's go into see the constraints. So say it said m and n is less than 100. So how we can save the previous calculation result? So we can use some metrics. So we can say saved. What is this one? This is a new. We have what maximum is 100, right? So we give his size is 101, and then we put it here. So we have saved. We know that one, right? So for easy to do is we can do if m bigger than n, we do this one, else we do n m. So what happened for that one? It means when you go to the recursive, we guarantee m and n, m should bigger or equal n. Okay, so we should do here. Okay, else if for saved m and n is not equal to 0, we directly use its value. Right? Else, so if m equal to n, right? Here we use this one to save the value. Will become what is that one? We guarantee m bigger than n, so this one will be the m map saved m n minus 1, right? If m equal to n. Else, this one will be so we can go in down or go in right. So, but every time we guarantee m is big and equal to n, right? So in that one we get its return value, and then we save it. So next time, if we have mn, we can directly use it. Okay, let's try this one. And remember last time, if we do not use dynamic programming, we cannot finish calculating. Now, try it. And sometime this LeetCode is, I don't know what is the reason. Sometimes same code, you can get it faster. Sometimes it's slow. So the best calculation time is 0 millisecond, right? So you can try multiple times. Sometimes you can get a very good calculation time. Okay, so this one is very hard to calculate the time complexity, because we use the dynamic programming, we can save a lot of time. So I think this one, at least the calculation time is close to big O m times n. For the space, you see this one, we have this one, so it still is the big O of m times n. Thank you for watching the video.